You caught me. Just trying to sneak in a quick snack before I got started here with the lesson with one of my favorite snacks, Velveeta. No, they're not a sponsor, at least not yet, anyway. Anyway, so now that you're here, I guess I'm gonna have to share, but I'm not gonna give you the whole thing. No way. I'll give you a fraction of it though, if you want. You don't know what a fraction is? Really? All right, cue the music.
Math vocabulary.
All right. Well, a fraction is part of a whole. Okay. So if I had a whole piece of a Belvita here, a fraction would be a part of it, not the whole thing, but I would be sharing just a piece of it with you. Okay. Um, Fractions come in really handy, and actually, it's something we're going to be learning about in this next module. So it's kind of perfect that you showed up while I was trying to sneak in a snack here. So let me go ahead and put up a fraction here so we can take a look at it. It's actually made up of two parts. Okay, a fraction has both a numerator and a denominator. So the numerator is the top guy, and the numerator tells us how many parts you're getting, basically, right? The denominator, ooh, easy for me to say, right? On the bottom, that's the how many parts in total. Okay, so for example, if I was going to split this Belvita with you, right, and I put it down here, and it's one whole right now, but if I were to cut it into two pieces, let's see, now, not exactly perfect, but you get the idea. So now out of that whole, I have two pieces. So the two pieces that I have would be my denominator, and if I gave you one of those pieces, well, you would have the fraction 1/2, one out of the two pieces, okay? So I think that's nice enough to be me to share with you. So here, go ahead, take a piece. All right, so now we both have our pieces, our fraction, our 1/2. So let's go ahead and, now you want some too? All right, so now there's three of us that gotta share this. So all right, give me your piece back, and let me put this back together, and we'll see what would happen if we split it into three pieces. So, all right, thanks, great. Let's see, put this back here. Just kind of wave a little. All right, so that looks better. Okay, so now we have this whole piece again, and I realize that this isn't like a perfect rectangle, right? But we get the idea if we were to square off the corners a little bit. So if we needed to split this into three pieces, because three of us were going to share it now, well, I would just split it into three equal pieces, right? All right, easy enough. So now if each of us got one of these pieces, we would be getting 1/3. So 1/3 is going to go to you. Perfect. 1/3 is going to go to you. Thanks. Go ahead and take that there. Perfect. Okay, and then I get 1/3 left over, so that's great. So we split that one whole into three pieces, so each of us got a third. I gave away 2/3, right? Because two of those three pieces went to somebody else. I get to keep 1/3 of it. So you kind of getting the idea of fractions here. So let's go ahead and enjoy our thirds now. And more of you, come on, I just want to eat my. All right, we'll share it. Give me back your pieces. Come on. Thanks. All right, perfect. Thanks. Okay, so let me go ahead and put this guy. Why is this one soggy? Come on, guys. All right, let me just put this back together here. Perfect. Okay, so now we could split this into fifths, right? We could basically split this whole into however many pieces we need. That's what fractions are, splitting them into the different pieces. So if I split this into 5 equal pieces, each piece would definitely be a little bit smaller because we're splitting that one whole into 5. Belvitas don't split perfectly into fifths, but that's okay. But you can get the idea here. I have 1, 2, 3, 4, 5 pieces. I had that whole piece, split it into 5 pieces, so now I have fifths. So everybody can get a fifth, right? And again, if I had these 5/5, right? I have 5/5. If I gave out to everybody else, I would be giving out 4 of those fifths. Those 4 of those fifths would be going out. I would be keeping 1 of those fifths, and then we'd go from there, which really doesn't seem like that much cookie when I think about it. But anyway, this actually was perfect because it worked as a good review of what fractions are and how fractions work and how we can make fractions out of a whole, right? So that was awesome. So let me go ahead and hand out these pieces to everybody, and then we'll get started. But before that, what's that behind you? Hmm? Well, must have been nothing. Sorry. Not sure what happened there, but let's go ahead and get started. For this, you're not going to need anything more than something to write on, something to write with, and make sure you have everything gathered up, and then we'll go ahead and roll into our lesson. All right, everyone, now that we got our snack on, it's time for us to get started and talk about fractions. So our goal for today is actually to learn about how we can make equivalent fractions and determine equivalent fractions. We're going to do that by looking at a couple different strategies that kind of illustrate what's happening when we make equivalent fractions. And for those of you that don't know what equivalent fractions are, Basically, an equivalent fraction is a fraction that may have different numbers, but it's actually the same amount, okay? So let's dive a little bit deeper into what that looks like, all right? So the first thing I want to do here is I'm going to sketch out a number line, okay? And we've all seen a number line before. This is something you've probably seen from kindergarten on, okay? And if I were to start at this number line, starting here with 0, and then I could have 1 all the way down here at the other end, and that's kind of like our one whole, right? Like we were taking a look at with the Belvita, for example. It represents the same thing. So if this is one whole, well, halfway in between, right? That would be 1/2. Right, 1/2. Again, that's how we represent a fraction. And this bar right here basically means divide, and we'll get into that as we go further on into the module. Saying right here 1/2 that we have one part of the two parts that it would take to make a whole. So saying that would mean if I had 2 out of those 2 parts, then I would have 1 whole. So 1 whole is the same as 2 out of 2. 2 halves, 1 whole. It's all the same thing, okay? We could go a little bit further with this by splitting it up, and we could say, well, if we maybe split this number line up into 4 pieces, right? So now essentially I have 1, 2, 3, 4 pieces, which means that this would be 1 out of 4 pieces. This would be 2 out of 4 pieces, which would be the same as 1/2. This would be 3 out of 4 pieces. This would be 4 out of 4 pieces. 4/4, 3/4, 2/4, 1/4. You get the idea. And we can kind of use a number line to help us visually represent fractions and even equivalent fractions. And we're going to come back to that in a second, but you can kind of see how this would work out in this way, okay? Let me get rid of this real quick. And we're going to take a look at another way that we can model fractions, and that's using something kind of like an area model, really, and it's just drawing out like squares and rectangles and stuff like that. So let me represent one whole like we did with the number line. Actually, let me just draw that number line back up here so we can reference it if we need to. Okay, so again, 1 whole, that's the same as 2 halves. We'll say this is 1/2, and we'll say this is 0, right? Maybe I should make that look like a 0 and not a 6. Okay, so I can also represent 1 whole, like a whole piece of something, by just drawing out a square, right? So this square right here, we could say is the same as 1 whole, right? No big deal there. Think of it as a waffle or a chocolate bar or whatever you want to think of it as. It's 1 whole of something. If I were to take this 1 whole and like split it right down the middle, all right, and then if I were to, let's say, color in one of those 2 squares, I would have 1/2, right? I would be representing 1/2, okay? So this is 1/2 of that whole, or 1 out of those 2 pieces, okay? So let me take that same square again, and what I'm actually going to do, I'm just going to copy it over here, okay? And we're going to use this to help us make some equivalent fractions. So what I'm going to do is I'm just going to draw a line across the middle of this now, okay? So now I have how many pieces total? 4, right? I have 4 pieces total, and how many of those pieces are colored in? 2 of them, right? But it's still the same amount, it's just a different way to write the fraction. I have more pieces that I'm getting and more pieces in my total. It's an equivalent fraction. So 1/2 and 2/4, they're equivalent. They're the same thing, okay? Let's take it one step further. I'm going to bring another copy of this over here. And this time I'm going to split it up into more pieces. I'm going to draw some more lines. So let's see. Perfect, okay? So now, what's the total amount of pieces that we have? 6, right? 1, 2, 3, 4, 5, 6. And how many of those pieces are colored in? 3, exactly. So 3/6 is an equivalent fraction. They're all the same. 1/2, 2/4, 3/6. You're still getting the same amount. We're just cutting it into different size pieces, okay? Like the individual pieces here are much bigger than the individual pieces here, which are even bigger than the individual pieces here, but we're still getting the same amount because we're getting more pieces, okay? So let's represent this change here numerically, using numbers, right? So if I have 1/2, to get to 2/4, to get an equivalent fraction, I can actually multiply by 2, 1 times 2 will give me 2. 2 times 2, of course, gives me 4. So it's 2/4. It's the same thing. We can move and make equivalent fractions by multiplying our numerator and our denominator by the same number. Okay? Likewise, to get to 3/6, I could do 1/2, and I can multiply by 3. Multiply by 3. 1 times 3 will give me 3. 2 times 3 will give me 6. And there we go. We've made another equivalent fraction. This time we made it numerically just by using numbers. So we can use our number line and divide up the number in different ways. We can use these squares, these rectangles, and color in the parts that we want, and then split them up different ways to find equivalent fractions. Or we can do it numerically just by multiplying by numbers that both the numerator and denominator by the same number, and we'll get an equivalent fraction. So it's all different strategies to accomplish the same thing. To me, I like this one in the middle sometimes because it helps to really illustrate what's going on. Like, you're getting smaller pieces, but you're getting more of them. So it kind of just helps me visually see it. I mean, this way is obviously the easiest and the fastest. You don't have to draw the pictures, but this kind of visually represents what's actually happening when we're making equivalent fractions, okay? So here's what I want you guys to do. If you would, on your paper, see if you could draw out a visual representation of the next fraction we can make, the next equivalent fraction we can make. Okay, so let's say instead of splitting this into 3 pieces, we're going to split it into 4 bigger pieces now, okay? So here we did 1/2, and then I split it in the middle. So we had 2/4, and then I split it 3 times. We had 3/6. I want you to split it 4 times. Now, split that 1/2 4 times, and let's see what we come up with. All right, I'm actually going to do mine up here because I've kind of run out of space. Make it just a little bit smaller. And if I was going to split my 1/2, I was going to make an equivalent fraction. Basically, I'm going to draw 4 across here. 1, my lines aren't super straight. 2, 3. Let's try that again. Have a little bit better of an effort here. Let's see. 1, 2, 3. Okay, that looks a little bit better. So now I have 1, 2, 3, 4, 5, 6, 7, 8. All right, so my fraction is going to be something out of 8. So let's see how many are still colored in. 1, 2, 3, 4. 4 of them are still colored in. So 4/8 is an equivalent fraction. And I know that because if I take 1/2 and I multiply numerator and denominator by 4, I'm going to get 4/8. 1 times 4 is 4. 2 times 4 is 8. Okay? I can really take that 1/2 and I can multiply it, the numerator and the denominator, by any number and make an equivalent fraction. So let's say, get this in again real quick, let's multiply it by, I don't know, 7. 1 times 7 is 7. 2 times 7 is 14. So 7/14 would be an equivalent fraction to 1/2. It would all be the same. I can multiply it by 157 if I want, and it would still be an equivalent fraction. Okay, it's referring to the same amount. We're just using some different numbers to do that. All right, so that's all well and good so far. But let's take this even further, and let's look at some different numbers and try to make some equivalent fractions, okay? All right, so let's try, let's just say if we had 2/3. Okay, so first I want to represent that visually here. All right, and I'm drawing squares, but you could draw rectangles. I wouldn't recommend circles. Circles are a little tough to work with, but this doesn't have to be like a perfect square every time, okay? But anyway, my number that I'm starting with is 2/3. So I'm going to draw it this way. I'm going to split it vertically first, okay, to draw my like original fraction. So if I have 2 out of these 3 pieces, I'm going to have 1 and 2, right? 2 out of 3, 2/3, okay? Perfect. I know my coloring's not perfect, but I think you can kind of get the idea. So now I could take that 2/3, I can make another copy of it right here, okay? And I could split that 2/3 to make an equivalent fraction. First, I'm going to start, just draw a line across the middle here. So now I've split it into sixths. 1, 2, 3, 4, 5, 6. So it's sixths. And how many of them are colored in? 4 of them, right? 4/6. So 2/3 is equal to 4/6. So I can keep going with that. I can make another copy over here. And this time we'll split it. Let's see, I did 1 last time. Let's do 3 this time. Draw some lines here. So now I've split it into 3 more pieces, right? 1, 2, 3. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6 of those pieces are colored in. 6/9, 2/3, 4/6, 6/9. They're all the same. They all mean the same thing. You'd be getting the same amount whether I was offering you 4/6 of my Belvita or 6/9 of my Belvita. You're getting the same amount. Even though these are bigger numbers, it's only because the size of our pieces changed. The size of our pieces actually got smaller, so you're getting more of a smaller piece. That's it. You're not getting any more just because the number's bigger or any less. You're just getting more of a smaller piece, okay? More pieces of smaller pieces. So, again, numerically, I could go from one fraction to another by multiplying. So we could see in this first example, we multiplied by 2, right? We split our one whole fraction into two more. So 2 times 2 gave us 4, 3 times 2 gave us 6, and we went from there. We split it again. For the next one, we went from 2/3 to 6/9 because we multiplied by 3. We split it into 1, 2, 3 sections. Okay, so 2 times 3 gave us 6, 3 times 3 gave us 9. Good to go there. And for this one, we might step out of our comfort zone a bit, but it's still going to make sense in the grand scheme of things, I promise. So we're going to start with a fraction of 5/4. Okay, and you might look at that first and go, Mr. Walker, that doesn't sound quite right. We've got a bigger number on top of a smaller number. But it's cool, right? It's cool. We call that improper fraction sometimes, but really it's not improper. It's just another way of writing a fraction. So I'm going to draw my number line real quick. I'm going to start with that 0. And if I were to take that one whole and divide it into fourths, right, because I'm looking at 4 pieces, so I would divide it, let's see, 1, 2, 3, 4, right? So I would have 1/4. I would have 2/4, which is the same as a half. We talked about that. I would have 3/4, and then 4/4 would be my whole. But I actually have 5/4, which means I would have one more fourth out this way, right? So it's actually more than one whole, which is fine. There's nothing wrong with that, right? So let me represent that with some boxes here. Actually going to make this look more like a rectangle just to illustrate that it doesn't have to always be a square. So let's see. Make this into fourths. Do some splitting here. Cool. And I know I'm going to have 4/4, so this whole thing is going to get colored in, but I'm actually going to need another rectangle over here so I can represent that 5/4. I'm going to color these in. So I know I'm going to have 1, 2, 3, 4/4, and then one more additional fourth, so I have 5/4. So in reality, or however you want to think of it, in another way, I have 1, and this is another 1, but I have one whole and then 1/4, okay? Just another way we can kind of think of the number. But let's see if we can make some equivalent fractions out of this. Let's see, if I were to take this and split these guys down the middle, right? How many total pieces do I have now? Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces, right? So our one whole is split into 8 pieces. Okay? All right. And you might be thinking, well, Mr. Walker, we have 16. If we count up all 8 of these, 8 over here and 8 over here, that gives us 16. Well, it doesn't, because really we're just looking at one whole. What did we split the one whole into? We split it into fourths, right? Working with fourths, right? And then when I drew this line across here, now we made it into eighths. Just because we have more than one doesn't mean that our denominator is changing. We're changing it to eighths, okay? So I have 8, and how many pieces are colored in out of those eighths? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 eighths. Okay, so our 10 eighths is the same as 5/4. To kind of illustrate that, drive that home a little bit more, let's do it numerically. 5/4, 5 times 2 would give us 10. 4 times 2 would give us 8. We multiplied the numerator and the denominator by the same number, and we can get an equivalent fraction. So this is a little background on making equivalent fractions, which isn't too hard, right? You can either use that area model type of thing to help you draw it out. You can use your multiplying by the same number, by the numerator and denominator by the same number to get an equivalent fraction. Any of those methods will work, okay? So hopefully this is starting to make sense as far as equivalent fractions go. And next we're going to take a look at how we can add fractions that have the same denominator, how we can add up some pieces to get a different fraction, not necessarily an equivalent fraction, but just being able to add fractions that have the same denominator. So thank you guys for hanging in there with me. Thanks for sharing a snack with me, and we'll talk to you soon. Thanks.